So, good morning, everyone. I'm Sylvain Goyette. I'm a PM in the strategy and ecosystem group. And I've been living and breathing performance tools and optimization for the last 10 years or so. You may have seen me at previous events a few years ago. I think it was back in 2013. So some of you may already be familiar with the content I'm going to present today, but we wanted to make sure that everybody is on the same footing and that all our partners and ODMs and OEMs have a full understanding of our performance tools and technical acumen to be able to deliver great Windows experiences to our shared customers. So yesterday, Jorge alluded to something similar. The fact that fundamentals correlates directly with good reviews of Windows systems. Like battery life, performance is a key cornerstone of a good user experience. And it shows when we look at reviews of devices on the internet. You can read here those reviews: super fast, extremely fast, and long battery life. So that's what we want to see. We want to make sure that our shared customers are happy with all the aspects of the user experience. So on our side, we can provide the tools, we can provide the guidance, we can provide analysis training, but eventually it's on your hands to make the right calls, make sure that as an OEM or an ODM, you apply all that knowledge and techniques to select the right hardware from the get-go for a specific form factor or price point, and then put on that hardware the proper image with a clean software stack that doesn't impact the user experience and the responsiveness of the machine. You only have one chance at making a good first impression, and we can help you with that, hopefully with today's content. So we'll try to rapidly cover a lot of topics in 1 hour. If I wanted to, or if we wanted to, we could spend like 2-3 days on performance. It's a broad topic, can be complex. I spent 10 years on the topic and I'm still learning stuff every day. If you want to learn more, there are 2 labs today. They're the same content, so if you miss the first lab, you can attend the second one. So come and we'll go through exercises to help you use the tools that I'm going to demo this morning. So our objective is to leave you with a good understanding of how to test Windows systems for performance. We're going to go through some high-level guidance on how to optimize your images and also present to you the latest updates in the OS and the ADK, the Assessment and Deployment Kit, related to performance tools. So we're going to go through the Windows Assessment Toolkit and the Windows Performance Toolkit. I'll spend about half of the presentation doing demos on my laptop. I'm going to walk through some of the exercises that we'll go through in the lab, just to give you a sense of what we're talking about. And then if you want to do it by yourself and go deeper and ask questions, then demos will give you context, and then you can come to the lab and ask those questions. So we'll start with fundamentals. So by fundamentals, we mean the set, or in this case, for the amount of time we have, the subset of knowledge required to be able to do efficient, not battery life, but performance analysis with the toolkit. So the hardware alone doesn't tell the whole story when it comes to performance. We get emails from ODMs and OEMs saying, well, it's a Core i7 with an SSD. Why isn't this scenario performing well? Well, you need to take into account everything. The whole user experience doesn't only include the hardware. It contains the OS, which we try to optimize on our side. And there's also the software stack. And that includes all the processes, all the value-add software that you preload on those systems that you sell to customer. So if there's an issue with a driver, there's an issue with one app in the background, one service, even though the hardware is fast, it could provide a bad user experience. So all the layers have to be optimized and iterated upon together when you do performance testing. So you could have one software package that is performant when you run it alone on a clean Windows image, but that performance can degrade rapidly depending on the target system you're running it on, or if there are other applications in the background starving the resources that this process critically needs. So as OEMs and ODMs, some of you also do software development. You have your own first-party apps that you put on the images. So the process I'm going to explain also applies to software development. So whether you're just building a system and you care about the image and the hardware, or you're building software, the same tools, the same process can be used to evaluate and design for performance. The first steps of the process, the first 3 steps here, are really to, from the get-go, before we even touch the hardware or start coding, is to design and plan, architect and develop, and instrument your code if you're developing code with ETW. So you need to have performance in mind from the get-go, even before you start testing. It's going to, as with anything, it's going to save you a lot of time if you have issues. So that means that if you're shipping to your customers a premium 2-in-1 device with Core i7, you shouldn't put in a 5400 RPM drive, right? I'm not saying you can't. You can do that if you want to, but in terms of user expectations, the user paying $2,000 for like Core i7 premium device expects top-level performance, and a 5400 RPM drive may not deliver that in all cases. So it's up to you to make the right choices in terms of balancing performance, power, form factor, but you need to be aware of customer expectations and what it means to ship a specific configuration and what it entails for performance down the line when customers are using that system. So most of what we're going to discuss today is actually related to the last 2. So this is where you test and measure and then analyze the ETL traces, what we call ETL traces. So it's the assessment toolkit, WPT. It's going to help you determine what's wrong. If you bump into a performance issue, you can diagnose the symptom, and then the analysis should be able to provide you with a root cause, and then you iterate on that. You go back, you fix the issue, you retest, you reanalyze, make sure everything is fine. This is all leveraging what we call the event tracing for Windows framework, which I'll go through in a few slides. So what should you test? So previous slide was about what is the flow, design through testing, through analysis. But what should you actually test? First thing, as a system builder, an OEM or an ODM, are system-level tests. End-to-end scenarios. That's stuff like boot time, browsing, video playback, making sure that all those things are flawless. Those are frequent user scenarios, and the user expects that to be fast. They show up as key performance indicators in most surveys that we do with our customers. And that's something we can provide. We have the Windows Assessment Toolkit. It already contains pre-canned tests. There's a boot test, a standby test, modern standby, video playback. All of that is already provided to you. So you just click, run, and you get results. Second thing are micro benchmarks. So if you have your own first-party app that you're developing, you should focus on key user scenarios within that app. Let's say you ship a tray icon applet that shows in the taskbar, and you preload that on your customer images, and you author that piece of software. Well, one key scenario would be the user clicking on the tray icon to show up the UI. So that would be one scenario to focus on. Now, even if the system is fast, right, it boots quickly, if your user tries to open the app, it takes 5 seconds to load up the UI, that's a bad first impression. So that would be a micro benchmark. And you can instrument that using our APIs. And the measurement of that scenario would end up in an ETL trace, and you can correlate the measurement of that scenario with CPU usage, disk usage, all using the framework. And then you use WPT to get the traces and analyze the traces. I'll demo that at the end. So on top of how much time does it take for a scenario to complete, you also need to have a holistic view of resource usage. And what I mean by resource, memory, network, disk, CPU. So if your scenario takes 5 seconds to complete, so let's say you have a big line of business app that you've authored, it takes 5 seconds to launch. Maybe you're okay with that, you say, the user expects that to launch in 5 seconds, that's fine. But if it's maximizing CPU usage at 100% for 5 seconds, then it can affect the rest of the system behavior. It can affect other apps running in parallel on the system. So when you look at those traces that you've gathered with our tools, look at how much time it took for a scenario to complete, and then look at what it's using during that scenario. Is it maximizing resource utilization? Is it optimized? Will it affect whatever else the user could be trying to do on the system at the same time? So I've been talking about ETW, the event tracing for Windows. So what is it? It's been part of the OS kernel for years. I think even back since Windows 7 and before that. So it's a fast, reliable, and versatile tracing mechanism. It can be dynamically controlled. You can turn on and off tracing for specific components dynamically without having to reboot the system. And the impact on performance is minimal. So we're talking like 1 or 2% performance degradation for a throughput of 10,000 events a second. So it's pretty efficient. It's built inside the OS kernel. And that's what we use internally at Microsoft to capture performance data. Even our telemetry data that we gather back in Microsoft to understand how the product behaves in the wild is using ETW tracing. So we're using what we recommend to you to use. And most of the kernel, most of the OS is already instrumented. So when you get traces, you see all the OS behavior. You see all the OS services, background processes in the OS. You see all of that, CPU, memory, disk, network, power data. All of that is given to you for free. If you want to instrument your code, you have your own service. You have your own application, Tricon, Updater, doesn't matter. You can use our APIs, all documented publicly on MSDN, to add your own ETW providers to your code. So if you have one scenario, it starts, it stops, you want to measure the elapsed time, you just want to log an event at the beginning, log an event at the end, and they're going to show up in the same tools that is going to show you CPU usage and memory. So you can correlate all that activity with system behavior. So when we talk about performance, we mainly mean responsiveness, which means the latency of an activity completing after the user initiates it, right? So unresponsiveness will quickly generate customer dissatisfaction. And there are 3 criteria to consider. And if you don't consider any of them, it's the quickest way to get bad responsiveness and bad performance on a system. So user perception should determine performance goals. What does that mean? Well, different operations will have different user expectation or acceptable speeds. Launching an app, that can take 1-2 seconds, right? And the user expects that. So that would be the target. That's how you define the target. Like, okay, this app should launch in 1 or 2 seconds on all the hardware I'm shipping. But clicking on the menu in the same app, 1 or 2 seconds to open a menu, that's not acceptable, right? That should be pretty real-time latency almost. And by that we mean like 100 milliseconds, 200 milliseconds. So studies show that the smallest delay the human eye or the human brain can perceive and be annoyed by is 100 milliseconds. So anything shorter than that, the user cannot even perceive it. So if you're in the realm of 100 to 200 milliseconds, for UI interactions, that's what you want. Second thing, measure on the right hardware. That's critical. If you have one piece of software or an image that you ship across a whole line of devices, make sure that it performs well on the low end first. You can even just focus on the low end. So I've got emails in the past, well, this piece of software performs well on our Core i7, but it's also preloaded on Core i3 or even Atom class CPUs back at that time. So, and they never tested it on that hardware, but they were still shipping the same piece of software across all the images. So make sure you test on the low end first, and if it performs well there, it's going to scale to the high end. Also test real-world environment. Some processes can be affected, as I mentioned, by the resources that are already used by background background processes. So if, for example, you test in a clean environment without any preload and your app consumes a lot of memory, it might not show any problem in your testing. But if you put the same piece of software on the image you're going to ship, and you have already a lot of processes consuming memory in the background, then you might end up with memory pressure issues, paging, page faults. And that's going to degrade performance quite rapidly. So never test in isolation on your, in a VM, test on what the users are going to get, what they're buying. Otherwise, you might miss critical problems. And when you look at ETL traces, as I mentioned, have a holistic view. And by resources, we mean both physical and logical. So physical, that's what we all know: CPU, GPU, disk, memory, network, power, but also logical resources. And by that, we mean critical sections, critical resources, mutex. So if we have software developers in the room, probably know what I'm talking about. If you guys are just hardware guys, then this is beyond the scope of what you guys would need to understand. But logical resources are also shown in our tools. So if you have a piece of code that tries to access a mutex to lock some block of memory or like a queue, that you can detect that. And if the thread is blocked 5 seconds on trying to access that synchronization primitive in the code, you'll be able to diagnose that with our tools. So just one example of one scenario, a fast startup, which is also known as hybrid boot. This would apply to any on-off transition, fast startup, full boot, standby, hibernate. We have tests for all of them in the assessment toolkit. So those scenarios are usually highly bound by the CPU and the disk. It's I/O and CPU intensive. So they're going to be heavily impacted by the software you preload and launch on every boot. So we have all the startup applications, the services, logon scheduled tasks that are being launched on boot. Those are usually defined through run keys or the startup folder, the start menu, legacy startup menu. And we see energy saver components, control panels, tray icons, updaters. All of that you guys usually preload, and it all starts on boot. So it usually causes starvation of resources, especially on low-end system. Like you have all of that, 10, 15, 20 processes all starting at the same time, and then the CPU is maxed out at 100% for like 25, 30 seconds. So if the user tries to open an application, launch a document, open the start menu, there's going to be a huge delay. So some of the guidance we have, don't launch unnecessary memory resident processes on boot. Really ask yourself the question, is it critical for my users to get access to that piece of software, that tray icon, like right when they get on the desktop? Does it have to be launched on boot? Can we just not launch it and the user will use it when they need it? If you really need to launch it on boot, instead of using run keys, you can use the task scheduler to delay the start time. So if it's okay for a process to be launched 1 minute after boot, to avoid using too much resources at the beginning of the boot time, then you can use the task scheduler to do that. There are ways to launch a process on logon and introduce a timer with the task scheduler. So you could launch 30 seconds, 1 minute after boot, and there's no way of doing that with a run key. And we've seen OEMs actually implementing that, and it works. You see their boot time decrease. So we're not just throwing that out there because we don't like you guys to use run keys. This works. So if you really need to use a run key and you really need to launch the app on boot, make sure that it's optimized. Sometimes you don't have control over that because it's a third-party app that you just bought and you preloaded. But if you authored the code, make sure that your developers, the dev team that did that for you, they know about the tools, they get access to this kind of training, and they know how to optimize and analyze performance for those processes. And one thing we've seen as well, manage code in the boot path. Like, I'm not saying .NET is bad, but when you launch a .NET process, you need to load additional resources from disk, all the .NET managed libraries. So if you have a 5400 RPM drive and it's already pegged by everything else being launched, if you have to load 75 megabytes of additional libraries in memory, it can take a long time. So just be aware of that. Again, plan accordingly, design accordingly before you even start testing. If you have any processes that are they're designed to do periodic activity like an updater or a scanner, that would be more for antivirus software, but like updates, scans, any maintenance related tasks. Instead of launching that on every boot so that it's always present in memory, you can leverage an OS feature called automatic maintenance, and the OS will take care of managing when this is executed. And it's pretty good. It's going to try to do it during the maintenance window, like at 2 a.m. Overnight, so that it's not interfering with the user activity when the user is using the system. And for boot, just a couple of guidelines in terms of analysis. I know we're going to cover that in the lab. But look at the memory footprint of services. Because when you shut down the system, all the services are not stopped, right? They just, they're paused and they're saved to the hybrid file on disk. So if you have a lot of preloaded software that's consuming a lot of memory, a lot of third-party services, it's going to increase the hybrid file, and it's going to be slower to shut down and slower to boot. If you add third-party drivers, security providers, like security-related DLLs for like fingerprint, stuff like that, that came from third-party, that can affect logon time. Now, we've seen issues in the past, 60 seconds timeouts. So logon time was increased by 60 seconds, was a hard-coded timer because one condition wasn't met. So you can analyze that and see that using the tools. But be aware of this can happen, and you can do what we call critical path analysis using the Windows Performance Analyzer tool. And we're going to go through that during the lab. And just simple CPU and disk resource consumption analysis during what we call post on-off. So after the desktop is shown to the user, we want the system to be responsive as soon as possible. So make sure to analyze that as well. And I'm going to do a demo with WPA. So we talk about a lot of things. It's a lot of content to digest, but just want to go through one more slide that's going to be useful for the lab and also useful in terms of understanding how sometimes CPU and disk consumption is not the issue. So how are resources utilized? So this is an example of one scenario. Scenario starts here, ends here, and the measurement is the elapsed time. So maybe the scenario took 5 seconds to complete. So you're looking at the ETL trace in our tool, and you see that there's one thread in one process that's responsible for completing that operation, right? And it's consuming CPU at the beginning, at the end, but it's not consuming enough CPU to explain why it took 5 seconds for the scenario to complete. So it might be waiting on something to be completed on its behalf. But on whom? No, it's pretty hard to tell if you just look at the task manager to do performance diagnostic. With WPA, you could see that thread 1 was waiting on thread 2, and thread 2 was processing something, was consuming CPU for like 4 seconds, and that's what caused thread 1 to be blocked. It was just waiting for possibly a resource that was owned by thread 2, and thread 2 was doing processing, and it delayed thread 1. You wish things were that simple. This is just one layer analysis, but that could go deep, like 15, 20 layers deep. And it can get complex and messy and confusing, but you can only build confidence by playing with the tools and just hands-on analysis. I can show you how to do that in the lab, but if you don't do it yourself and practice, it's a hard skill to hone. Thread 2 could be waiting on something else, maybe waiting on the third thread, and the third thread is doing disk I/O, so we have no dependency 4th level deep, and eventually everything resolves to a disk I/O, so it comes back with a DPC, a deferred procedure call. All of that can be done and understood with WPA. So just want to give you a sense of what's possible to do with our tools. You can follow that control chain and do the full analysis and understand why your process or why logon took a long time. Now, if you look just at the logon events, you might see, oh, it took like 60 seconds to authenticate the user. Why? You could diagnose a 60-second wait chain using WPA. That's what our performance team internally does all day long, like all year long, to optimize the OS. They gather ETL traces and they do this kind of analysis, and then they go back to the feature teams. Okay, we found you have a dependency here you could remove, or there's a bug there, it's consuming too much CPU, it's stuck in a loop at that level, go fix that. And then if we reduce this, we reduce the elapsed time of the scenario. That's the kind of analysis and diagnostic you want to do. So that's all for the context and the fundamentals. I'm already, a bit behind schedule. We'll go. It'll be fine. It's a lot of content, so don't hesitate to come to the lab to ask questions. So the Windows Assessment Toolkit updates, that should be quicker to go through. So before we go to the ADK itself, just FYI, there's a new task manager, GPU graph view. So if you right-click on the taskbar and open the task manager, and you go to the performance tab, you're going to see there's a new graph. Oh, wrong button. GPU. So it shows you GPU usage on the system real time. And the data comes directly from the GPU scheduler and the the graphics kernel and video memory manager. So it's available, the data is available no matter what API is used to do the graphics rendering, whether it's OpenGL or DirectX or name it. It all goes down eventually to the graphics kernel, and that's where we're getting the data from. So this is very precise. It's more accurate than third-party software to measure GPU usage because those third-party utilities don't have access to that data. But it requires WDDM 2.0 or above. So if you're interested in graphics, gaming, diagnostic, you can use that. So you have two types of graph, one for GPU utilization. You're going to get one graph per GPU unit. And you also have video memory. Yeah, here at the bottom, you have the video memory being used. And also, if you go to the details tab, it's probably hard to see for the folks back of the room. So this is in the performance tab. If you go to the details tab, per process, you're going to see the GPU utilization for each process. So there's another data point available in the details tab. It has to be manually added. There's a blog post on this topic if you want to read more about this. So for those of you who are not familiar with the Windows Assessment Toolkit, it's been available since Windows 8. I was originally 10 years ago on the team that built that kit, so coming full circle. So it provides a set of performance tests, as I mentioned, browsing, video playback, boot time, standby, hibernate, all of that. It's easy to use. It also covers energy efficiency, as Jorge mentioned yesterday. There are battery life tests in the same kit. So in terms of performance, we have a few updates for a fall creators release. We have a new media playback assessment that generates audio and video quality metrics for glitch-free playback. We have a new productivity and video playback energy efficiency workloads. Jorge mentioned that yesterday. And just FYI, so you're not worried, we did deprecate out-of-date energy efficiency workloads. So if there's a test you used to use in your lab and it's gone, it's probably on purpose. It was all replaced by the new video playback energy efficiency workloads. So we had, I think, 4 or 5 different playback workloads that were all unified in a single test. So everything else was deprecated. And the tests produce metrics like boot time, app launch time, memory footprint. You have stats on audio, video glitches, battery rundown stats. So if you're not aware of the kit, go download it. What we're planning for the next 2 releases, we're going to try to do as much as we can in the next OS release, but some of that may be pushed to the subsequent one. So a lot of good stuff is coming up. Our team took ownership of the kit last release, so we ramped up, and now we can deliver more goodness to you guys. Edge web browsing EE workload, so battery life testing, browsing the web with Edge. YouTube streaming EE workload, so playing a YouTube video in Edge full screen and measuring battery life. Hibernate EE workload. So that one is like more lower priority, but if you want to measure the battery drain while the system is in S3 and S4, it's available. It will be available. That one is already coded. It's in the code base, so it'll be in the next release for sure. Skype EE workload, so measuring battery life duration while having a Skype call. PowerView E3 log viewer tool. I don't think that Jorge went through that yesterday, but there's a new tool. You talked about E3 yesterday. We're checking in a tool to visualize in a UI the E3 data. So that's going to be added to the ADK. So that's more on the battery life side, but I'm PMing those. Performance. We're going to have a new Microsoft Office application launch, document open assessment. So if you're interested in measuring how much time it takes to launch Excel, open a spreadsheet, start a PowerPoint slideshow on your machine, the test will be available to do that. UX responsiveness. So it's going to be a test to measure the responsiveness of the OS UI. So we're going to start with 2 scenarios. Interacting with Cortana and opening the start menu. So how much time does it take to do those 2 things? So is the UI snappy, right? And if you have, if the user plays a video in the background, so you can simulate that manually, run the test and see if it affects the responsiveness of the system. We're also going to do some updates. A new, it's not a new assessment, it's already in there, but we're going to update the modern standby assessment. We're adding new capabilities to it. The ability to test both connected and disconnected standby. The ability to test modern standby on AC. The ability to test modern standby on AC with simulated batteries. So we have a simulated battery driver. So you don't have to, basically the objective is to automate the whole thing without user intervention. So you don't have to have somebody in the lab that pulls the cord of the machine to test on DC. You could just test with a simulated battery. And then, so the updates for modern standby are both on the performance side and the battery life side. And then we're going to add media diagnostics to the media quality assessments. So automated diagnostics, being able to extract remediation and guidance on how to improve media quality playback automatically using the ETL traces. So that's what's coming up. Hopefully we're going to be able to do all of that in the next release, but again, might get pushed out to the next one. If you want to get the ADK, You can download the RTM version from the developer portal. And if you're a Windows Insider, there's also a link on the Windows Insider portal to download the latest version. So I don't think we've started to release ADK preview builds for the next release yet, but it should come up pretty soon. So when you install the ADK, make sure to select Windows Performance Toolkit, Windows Assessment Toolkit, and Media Experience Analyzer. Everything else you don't need. No, you don't need for performance testing. So those are the three things you would need. And we've actually reduced the size of the kit. So it used to be like it was taking like 3.5 gigabytes to install the whole thing. It's down to 1.9, so it's much better. So the new quality assessment for media. Jorge presented yesterday the workload, the battery life workload, but basically you can go through the same scenarios and analyze the quality of the playback. So we have local video playback, we have streaming, we have the movies and TV app, Halo 2 Clip, we have Netflix. So all of those scenarios that Jorge mentioned yesterday for battery life testing, you can run them and gather quality metrics. And by quality metrics, we mean audio glitching, video glitching. So make sure that the playback is smooth and there are no issues while playing the video, because that's totally different than battery life. You could have a very long battery life playing a video, but maybe it's glitching every 2 seconds, right? So it's a bad user experience. So that's what this test is for. And you can see here the metrics. Video glitches, total count, audio glitches, and you see the type of glitches. And there are training videos on Channel 9 recorded by Jorge on how to analyze that kind of stuff. But this is the new assessment, the unified one that does all of that. And when I said we were working on YouTube and Edge, it will be a new option in that menu. So it's going to be integrated to that unified media quality assessment. I'll just demo that, how to create a job in the ADK. So that's all for the content. Still have 20 minutes to go, and I'm just going to go through demos. Okay, perfect. So once you've installed the ADK on your system, you're going to get a tool called the Windows Assessment Console. Here, Windows Assessment Console. And that would be the center hub to do all the performance testing, job management. So that's the UI that you get. And if you click here on Run Individual Assessments, you see all the tests that we have. Fast startup, full boot, Edge, file handling, which does copy, move, delete, and zipping files. Hibernate, we still have the old IE test in there. We have memory footprint, mini filter diagnostic. You can ignore that. That's more for the anti-malware vendors. Out of the box experience performance, that's UBI. So it's to measure how much time it takes for the user after they just bought your system, power it on for the first time, the amount of time it takes to go through UBI. So is it within 2 minutes or like 10 minutes to complete UBI? You can measure that using that test. It requires some manual intervention. You need to manually enable a few things like on the first UBI screen, but the rest is automated. We got standby, which is S3, and Windows 10 media playback quality. One question I often get, and Windows Store app performance. We've actually renamed that to the Microsoft Store, so that's an old version. It's been renamed in the next one. So don't be afraid that the test is gone when you get the next release of the ADK. You're going to see Microsoft Store Performance Assessment. It's the same test. So you don't see any of the jobs that Jorge talked about here. To get access to the energy efficiency jobs, you need to go to the Options menu, New Job, and you create an energy efficiency job. When you click on that and you add assessments, you see the workloads that Jorge talked about. So file handling, idle, modern standby, productivity, and the last one is the media playback workload. That's the new one that Jorge mentioned. So you can package assessments together. New job. So for example, I could decide to test boot time, and then Edge, and then Windows Store App Performance Assessment. Here, it means I need to enter a required parameter. So I want to test, for example, the Xbox app, how much time it takes to launch the Xbox apps. So this is going to create a job, and I can either run the job right away on this system or package the job. It's going to create a folder, self-contained folder, that you can then copy on any system and launch a script to do the measurement. So once you've done the execution, you get a nicely formatted report. Well, not nicely formatted if you try to read it directly from the XML file. So it's just one big, gigantic, in fact, XML file. But you can open it. So that's something people don't know. They get the report and they parse it like in a text editor to extract the metrics. You can open the results from the Windows Assessment Console. So here what I did is to run the fast startup test on my machine with a clean OS image. And you can see here I got shutdown time, BIOS initialization time, boot time. So it took 14 seconds to shut down, BIOS took 2.5 to post, and total boot was 12 seconds on a clean image. And then I put an OEM image on the same system. I redid the testing, and I got this other result set. So interestingly, the OEM image is shutting down in less amount of time. Interesting. I didn't analyze that because that's goodness. Yeah, there's nothing to complain about. There's no issue with the OS. Here, BIOS post went up to 4.5, so that's interesting because it shouldn't change from run to run. But we clearly see that boot time went more than doubled. So then we can expand this, and we see how time breaks down. Main path is the amount of time it takes from power on to desktop. That has slightly changed on the OEM image, like 2 more seconds. But most of the delta is in what we call post on-off duration. So 16 more seconds. And post means it's a heuristic-based metric. It's not relying on discrete events to measure the stop time. So it looks at CPU and disk consumption at normal priority or above, and it tries to estimate how much time it takes for that usage to drop to an acceptable level, like close to 0. And that means, on paper, in theory, that the system is responsive, right? Because all the background processing has completed. So just from experience, that probably means there's a lot of third-party processes on the OEM image are all launching at the same time once the user gets to the desktop. And you can go down one more level if you expand main path boot. You see hybrid file read duration doubled. So the 2 seconds, the two more seconds we're getting here to get to the desktop, it's mostly spent reading the hybrid file. And if we go down one more level, we get the hybrid file size. Well, it's 500 megabytes and 220 on the baseline. So there's probably a lot of services from third parties consuming memory on that OEM image, doubles the size of the hybrid file. So the solution may not be to just remove all of that from the image, but go back to the vendors, go back to the dev, look at your memory usage. Is there a way to optimize that, right? Or maybe it's a memory resident process that is not needed on every boot. So maybe it could just still be on the box, but not launch on every boot. So there are no mitigations, there are solutions to that kind of issue. And for hybrid file diagnostic, if you want to know what contributes to the hybrid file size, there's an optional diagnostic checkbox in the assessment configuration you can opt in, and it gives you hybrid file diagnostic. And if you expand that, you see where the memory in the header file goes to. So we have a minor increase, like 20 megabytes in driver allocations, but it's mainly coming from working sets of processes. And if we expand that, and we sort descending, we see that, oh, our friendly anti-malware service here is contributing 200 megabytes. It probably, in that case, the issue was that instead of having a Bloom filter data structure to load their signatures, right, load them intelligently, they were just loading all the signatures from disk and putting that in the cache, right? Just increasing significantly the memory footprint. And that goes into the header file when you shut down and you boot, right? And if you look at the baseline and you look at Defender, Windows Defender, which is our AV, our footprint is a quarter of it. So in this case, the regression in header file size mainly comes from the AV, third-party AV. So for every assessment in the ADK, you have this kind of report. So all the top-level metrics are surfaced in that report, and you can drill down through the metrics this way. But backing all of those reports are ETL traces. So you have performance traces with ETW events for each measurement, for each iteration of the test. So by the way, if you right-click here, and you can show the iterations, and you see that the top-level number you were seeing is actually an average of 3 measurements. So you can see which measurement. Sometimes there's a one-off issue, an outlier, like one run took 60 seconds and the other 2 took 12 seconds. So the average is not really useful in that case. So it's always useful to look at the iterations individually, make sure there are no statistical outliers in the data set. But all the iterations are backed by an ETL trace. And when you open the ETL trace, you're going to see our WPA tool. So that's the main tool you're going to use if you come to the lab. But basically, you can see here computation. That's CPU usage, storage, disk usage, memory, power. So all the events are segmented by logical KPIs, key performance indicators. So in this case, we're looking at fast startup. So there are analysis profiles already defined for fast startup. You go to the profiles menu, you click apply, browse catalog, and there's a fast startup WPA profile. If you open that, it's going to change the UI a little bit, and you're going to see there's a deep analysis tab, and you can see the breakdown of all the phases of boot visually on a timeline. So all the metrics we were seeing in the ADK report are also visualized on a timeline. So reading the header file occurred here. Then we resumed devices. Then we went through WinLogon, and WinLogon took a good chunk of time. Then we had post-boot here. So you can see exactly where the time is being spent visually, and then you could zoom in. So for example, here I see a big spike of CPU usage. I can select this time interval, right-click, zoom. And here, obviously, there's a problem. Like this process, RWS, is using 100% of the CPU for 5 seconds. Not a good thing to do on boot, right? So that's the graph. You can see visually, the usage. And then underneath the graph, you have the backing data. And you see the process list. The stacks would show you what the processes were doing in terms of CPU execution. Wait basically means no CPU time, so 15 seconds. And that's 43%. of CPU usage average for the interval I'm looking at. If I zoom in more, like really close to the spikes, it becomes 90%. It really depends on the interval you're looking at. So how do you get the call stacks to understand what the process is doing? So you need to have the symbols of the OS and the process you're interested in. So for the lab, we ask you guys to download the OS symbols for RS3 RTM ahead of time. So they're all installed on my PC in C, symbols. So those are all the RS3, not RS3, but creators update, fall creators update OS symbols for RTM. You go through the traces menu, configure symbol path, make sure that it points to either the public Microsoft symbol server or the local symbol cache that you've downloaded. You can also add multiple folders if you have no symbols, PDBs for your own processes. You can put the PDBs in the separate folder. And then you load symbols. So it could take a long time. That's because I have the cache on my computer. And then if I expand this, oh, that trace was not gathered on the right build, or I don't have the right symbols. But basically, you would see the function names here. So you would see RWS, and then there will be a function within that process. So then you can go back to the developer and say, okay, this function specifically is consuming the CPU. I'm not sure why this didn't work. It was working last night. So that's just to give you an overview. The lab will go through more than that. So that's WPA. There's also WPR. So let's say you want to gather a trace for any scenario, not just the ones that we have in the assessment toolkit. You can open Windows Performance Recorder if you've installed the ADK. So WPR. And then you can enable providers. So let's say you have one app that you've authored and there's a performance issue. When your users are clicking on the menu, it takes 5 seconds, right? We don't have a test in the ADK for that. You'll need to write your own test. And to get the performance data, you would use WPR. So in this case, we're not sure what the issue is. We just know there's an issue with the process. So you would select the first level triage option, which will gather lightweight tracing for CPU, disk, memory, power, everything, right? To help you triage what the issue might be. If you know it's a problem with the CPU or a problem with the network, then you could select CPU usage, network IO activity, but the traces will become bigger and bigger and bigger, right? And at some point, it might actually impact system performance. So always start with first level triage, then you might have an idea of where the issue is. If it looks like it's only on the CPU, then only enable CPU for the second trace, the second repro, right? If it looks like it's the disk, enable the disk usage. And then you just click start button, go through the scenario in your app, reproduce the issue, go back to the WPR, stop. You're going to get an ETL trace, and then you open the ETL trace with WPA, and then you start playing with CPU usage, disk usage graphs, and try to do the diagnostic. Jorge mentioned yesterday that WPR ships in box on the command line. So that's only available if you've installed the ADK. But on any installation of Windows, there's actually a WPR tool. So here I have the ADK installed, so you see the path to the ADK. But you see it's also sitting in System 32, WPR command line. So you could, on any system out there, just do WPR start general profile, and it's going to start tracing. If I do that, make sure that you are. I'm already tracing in the background, I think. Or I'm not using. Where is it? Duplicate instance of Windows Performance Recorder Control. Oh, because I have the UI open. Need to close it first. It's tracing, then WPR, stop, test.etl, going to save the ETL trace, then I can open it in WPA. And if you have your own code instrumented with your own providers, you can write what we call a WPRP, a Windows Performance Tracing Profile. Here I have one for the lab. It is a WPRP file. Whoops. So UI deleted WPRP. That UI deleted.exe binary is instrumented with ETW tracing APIs. And if you want to gather those events along with CPU events, disk events, you create this. So it's a simple XML file. So you create an event collector. You can define the amount of memory buffers and size to catch your events. And then you enable it here. So UI delete provider would match the name of my provider in my code. So I would just tell WPR, use this WPRP file, start tracing general profile, start tracing CPU, and you're going to end up with one single trace that has both the first level triage providers, the CPU providers, and your providers from, in this case, the UI delay.exe process that has its own provider in it. And you would be able to correlate those events with CPU usage and disk usage. That's one exercise we'll do in the lab, how to do that, and also have the simple code available on GitHub. This is all documented on MSDN, but the simple code here, here's how we define, it's simple. This is in managed code. One line to define the provider, and then one line to log an event. And this goes straight into the ETW tracing framework, ends up in the ETL trace. So this is all available on GitHub for the lab this afternoon. And that's pretty much it for the demos. So I walked you through very quickly what we'll go through in the lab. But yeah, so feel free to come in later today. So, the clicker, yeah. So call to action. So today should be the beginning of performance relationship. Like if you have any questions, any feedback, if you're familiar with the ADK and there are tests you've been wanting to see for years, now is the time to ask. Our team owns the kit right now, so we're open to feedback and we want to deliver the test that you guys are interested in. So let us know. Optimize the right scenarios. Focus on what we discussed today: boot time, edge, file copy, memory footprint, video playback. All of those scenarios that are in the ADK, they're there for a reason. We know that they affect user satisfaction. So start with that. And if you have your own software that you're preloading on user systems, take performance seriously. Tell your dev teams, make sure that you follow this kind of guidance and optimize the processes so that it delivers good performance. Because writing bad code is easy, right? So sometimes deadlines are important, but always have in mind at least some level of performance engineering in mind. Leverage our tools and guidance, and attend the Performance and Power Labs. I think the Power Lab is right after this, or it should be starting in 5 minutes, so I'm going to wrap it up. Just know there are a couple of training videos that go a bit deeper on Channel 9. So just me and another guy talking and doing demos. So it takes about 20-25 minutes to watch the video, a couple of them, and we're planning to add more and more. So again, it's a discussion. If there are topics you would like us to record videos for Channel 9, let us know. If there's one thing, I'm always interested to know how to diagnose what's going on with UI delays, like in UWP apps, right? We could record a video for that, right? Just let us know what is of interest to you. And that's it. 2 minutes late. No, not too bad. Thank you, and see you at the lab.